Hi, welcome to this lesson on Euclidean geometry, the Pythagorean theorem. Let's have a look at question 1. So we're given triangle PQR, and we're told that angle Q in that triangle is a 90-degree angle. And we're also given the line QT is perpendicular to the line PR as follows. If we're given that PQ is 7 centimeters and QT is 3 times root 5 centimeters, then determine the values of PR, which is this long hypotenuse length of the blue triangle, and QR, which is the adjacent side of that blue triangle, to the nearest integer. Okay, so I see 3 right angled triangles. I see the large triangle, PQT, and this is 7 centimeters. Then I see this smaller triangle here. Okay, this is PTQ. So TQ is 3 root 5 centimeters and PQ is 7 centimeters. And then I see a third right angle triangle there, right? Because this is a 90-degree, angles on a straight line. So that's going to be TQR, and it's going to be 3 root 5 centimeters. Okay. So looking at these triangles, these 3 right angle triangles, the one that has the most amount of information I would say is this one here, PTQ. So we can actually work out the length of PT rather easily using the Pythagorean theorem because we know this is a right angle triangle. So I can say by the Pythagorean theorem, we have that PT squared plus TQ squared equals PQ squared. So we have PT squared plus TQ is 3 root 5 squared equals PQ 7 squared. Okay, so I can bring over this term to the left-hand side. So 7 squared is 49 minus, so let's do 3 root 5 squared. That's going to be 3 squared is 9 times root 5 squared is just going to be 5. So it's going to be 45. Okay, so 49 minus 45 is 4. Therefore, if I take square root on both sides, I would get algebraically plus or minus 2. But from the context of the question, we're dealing with lengths of triangles, so PT is just positive 2. So that's 2 centimeters. Okay. All right, so now we need to find PR and QR. That was the original question. We've only so far found PT. So now you've got to ask yourself, in this triangle, you're looking for this length here and this length here. Okay, we don't have enough information on that diagram to proceed, but we do have other right angle triangles with a lot of information. So let's try and use similarity of right angle triangles, okay, to go ahead and find proportions that we can then work out. Okay, so I'm going to consider the following 2 triangles. Consider triangle PTQ and triangle PQR. So I chose PTQ because it has the most amount of information, and PQR because that's the triangle that I'm actually looking for information on. Okay, sorry, this big triangle should be PQR there. Okay, so I'm going to show that these 2 triangles are similar in that order. Okay, so let's go ahead and prove that. Well, first of all, angle P is equal to itself. It's a common angle. So I can say in this triangle QPR equals QPT, that because it's a common angles are equal to each other. All right, and then I also have that angle PQR, which is 90 degrees, must be the same as angle PTQ. Okay, so both angles are equal to 90 degrees. That was given. All right, so therefore, the last angles here must be equal to each other by angles in a triangle. So angle PRQ is equal to angle PQT. That is by angles in triangle. So I've shown angle P is equal to itself, common angle. I've shown angle Q equals angle T by 90 degrees given, and I've shown now that angle R equals angle Q by angles in a triangle. So those 2 triangles are indeed similar to each other. So now that we have similarity, we can go ahead and use proportionality of those similarities. Okay, so let's make some space here. Okay, so let's just state what we've proven. We've proven that triangle PTQ is similar to triangle PQR. Okay, so now I'm going to use the relationship, okay, PR divided by PQ. Okay, so let's say PR divided by PQ. Okay, the reason I'm doing that is because I'm going for PR first. So on the left-hand side, I do the exact same sequence, PQ, right, and that will be divided by PT. Okay, so PR is what we're looking for. If I cross multiply both sides here, I get PQ all squared divided by PT. And that's nice because PQ we know was 7. So that's 7 squared divided by PT, which we just worked out. So that's going to be 2. So you're going to have 49 over 2. And 49 over 2 is, so that's going to be, so 50 over 2 is 25. That's the closest. So it's going to be 24 and a half. Okay, but to the nearest integer means we round it up to 25 centimeters. Okay, so that's 25 centimeters. And we know that was 7 centimeters. So therefore, we can use the Pythagorean theorem here on this right angled triangle now to work out the length of QR. So I can say that PQ squared plus QR squared equals PR squared. So PQ is 7 squared, QR is what we're looking for, and PR we worked out to the nearest integer is 25 squared. So therefore QR squared is equal to 25 squared. So there's a nice trick when you square numbers ending in a 5. So I take the 2 multiplied by 3 gives me 6, and then 5 squared is 25. So that's a nice little trick. And then minus 49. So let's check what that's going to be. So I'm going to bring up the calculator, and then we can double check that. Okay. So let's just get the calculator up. Okay, so you're going to have 25 squared minus 7 squared. It's going to give you 576 centimeters. So therefore QR is going to be the square root, the positive square root, because it's a length, right? So when you talk about lengths, you're talking about positive numbers. So the square root of that answer is 24 centimeters. Okay, so this is 24 centimeters, and that is the 2 lengths rounded off to the nearest integer for both. Awesome. I'll see you in the next one.